Unmute your speaker or increase volume. All right, let's see how this works. All right, here we go. Hopefully that's working. Now, for today, you should have been able to plug these in relatively easy. So for the first X values, you're going to plug in what? All right, -1, 0, 1. And when you plug -1 in, you get what? When you plug 0 in, and when you plug 1 in, anybody have a problem with that? Now we plot those points. -1 and 7, 0, 4, 1, 1. And that should make a line. All right, anybody have any questions with that? All right, so for the next one, number 2, we're going to plug in what? And then we end up with, right, see, I told you, very easy. -1, -7, 0, -2, 1, 3. All right, then you graph those lines, or you connect the dots here. Anybody have any questions with that? And finally, the one that might give you a little bit of trouble if you didn't pay attention yesterday, but we're going to plug in what for X? -4, 0, and 4. That is correct. No, I didn't say multiply by the reciprocal, right? You want to eliminate the fractions. To eliminate the fraction, you just multiply by whatever's in the denominator. All right, so we're going to do -4, 0, and 4. When we plug in -4, we get what? Okay, so just to make sure, y equals -3/4 times -4 minus 5. So what happens to the 2 4s here? They cancel, right? So a negative times a negative is still a what, though? Positive. So that's 3 minus 5. Be careful. -2, right? And if we plug 0 in, we get what? -5. That was the easy one. Now, plug in 4. -3/4 times 4 minus 5. The 4's cancel this time. So it's, yeah, -8. Now plot those points. -2 or -4, -2. 0, -5. 4, -8. It will make a line. It doesn't matter what points you select. It will make a line. All right. It's just a matter of which points are easier to select. You see what I mean? I don't want to deal with the fractions, so I plug in numbers that are divisible by 4. All right, flip the page. All right. Now for question number 4. All right. If we want to do the same way we did, we're going to plug in what? Yeah, so everybody plug in -2, 0, and 2 and see if you can come up with the 3 points. All right, when we plug in -2, what do we get? -1. Plug in 0, 4, and plug in 2, 9. All right, now let's plot those points. -2, -1, 0, 4, 2, 9. And once again, they should all line up perfectly. All right, now you can put a star by number 5. This is something new. All right, now again, not something you need to memorize, but this says that the y value is always what? The y value is always -5. So you just put -5 in for y. And the x can be anything, just like we said, -1, 0, 1. All right, so now please plot those 3 points and then let's talk about what was created. What was created? Yeah, you don't have to say straight. Remember, lines are straight. Saying straight line, that is redundant. No reason to say straight line. All lines are what? They should be straight anyway. That's what makes them a line. All right. So what type of line is that? What do we call that? Some people think it's vertical, but it's really what? It's a horizontal line. All right. Anytime they ask you about y equals, I need everybody to remember that it is going to just be a horizontal line. All right. It is a horizontal line going through whatever that value is, going through y equals -5. All right. So in the future, you just have to put a dot at -5 and make it horizontal. All right. Star on number 6. We don't want it to be -x. We want it to be what? Positive x. So what do I do to make it positive x? Yeah, you just multiply by -1. So I want everybody underneath that to put x equals what? X equals -4. Bless you. All of the x values now are what? All of the x values are -4. So what can the y values be? Whatever you want. All right. But in this case, it's good to go with what I was showing you, -1 and 0 and 1. So now plot those points and let's see what happens if you graph that. -4, -1, 0, and 1. So that creates a what kind of line? Yes, there you have it. It's all right. It doesn't matter. It doesn't matter. You're allowed to be wrong. All right. Don't worry about correcting people. All right. X equals is a vertical line. All right. It's a vertical line. X equals -4. All right. Now I'm going to pause for a second. And now we're graphing using the X and Y intercept like we did yesterday. 7. Let's just do 7 and 9. Well, if you want, you can do all of them because that's going to be your homework, but I'll just do one of them. Everybody try 7. All right, let's see what that is. Give you a second. See if you can do it. Much better. Okay, here we go. Now, when you want to graph using the intercepts, we need a 0 for the y and a 0 for the what? X. So if you plug 0 in for y, come on, people. If I plug 0 in for y, what do I get for x? -3. If I plug 0 in for x, I get what? Come on, that's how easy. All right, right above x-intercept, do me a favor, just for practice, y equals 0. Anytime someone asks you for the x-intercept, your brain should say it's just when y equals 0. When somebody asks you for the y-intercept, your brain should say, when does what? X equals 0. Good for you. What? Yeah, because if I plug 0 in for y, look, I get 2x plus 3 times 0 equals -6. 2x equals -6. X equals -3. You see what I'm saying? Yeah. And the same thing with the other one. 2 times 0 plus 3y equals -6. 3y equals -6. Y equals -2. Makes sense now, right? Yeah. All right, so here we go. So now we plot those points. -3, 0, 0, -2. And we graph that line. And we call that graphing by using the intercepts. All right. All right, you can knock those out, 8 and 9 out, and 10 and 11 and 12. All right, just to make sure. Let's go do number 12 together, just so I don't give you so much homework. All right, let's see if we can do 12. Come on, everybody drop down to number 12 real quick. Good for you. Tell me. Come on, speak up. Y is what? Yep. And for you are amazing. That's it. All right. So now we graph -6, 0, 0, -6. And here we go. Anybody have any issues with that? Anybody? All right, flipping the page. Now, last year I did this on your iPad. All right, so I put blue and red lines, and then the subscripts are for blue and for red. Does everybody agree with that? Does everybody see that? But the problem is when I print it out, it's not blue and red. All right, does it really matter? No, there's two lines, and we want to calculate the slope of each line. All right, now most people don't understand slope, so please look up on the board so I can show you how simple slope is. All right, it's really easy. It looks really complicated, but once again, remember I told everybody, everybody's in the same boat. No one knows more than anything about this topic. All right, we're all in the same. All right, so slope is how you describe lines. All right, so this slope right here that I want to draw, I want everybody to understand they have to give it a numerical value. That value is 0. The slope of that line is 0. I'm going to explain to you what slope means in a minute, but I just want you to think about it. Now, what's happening to my line? What's happening to the slope? It's getting bigger. Thanks. You can think about when you're hiking up that mountain next week. All right. The steeper the slope, the harder it is to climb. We agree with that. All right. So I always tell kids slopes are positive and negative. So when you climb up a mountain, the slope is what? Positive. When you're going down the mountain, the slope is what? The slope is negative. Now watch. This slope is positive. This slope is what? Negative. Well, then I have some brilliant kids say, well, what if I was walking this way? That looks like the slope is what? The problem with that is you have to understand you read numbers from what? You always read numbers from left to right, from small to large. So you're always walking up the mountain or down the mountain from left to right. All right. So this we say is a positive slope. We say this is a negative slope. And we say this slope right here is what? 0. All right. Now, the steeper, the greater. So now look right here at my new line right here. The slope is getting bigger and bigger and bigger and bigger and bigger. And all of a sudden, it becomes vertical. All right. Can you climb up that mountain? No, you really can't. Some of you might try. All right. But you can't. All right. That's vertical. All right. You cannot climb up that mountain. So I try to remind kids that a vertical line has a slope, we say, that is undefined. All right. The slope of a vertical line is undefined. All right. Now it's not undefined in the, like it doesn't have a definition. All right. It's undefined based on a fraction. All right. Now let me give you the formal definition of slope. All right. And this is what's important. It's on the SAT a huge amount of time. All right. It's on the ACT. It's on everything. We have a whole study of calculus is based off slopes. All right. So again, slope you'll be seeing for the rest of your math career. All right. Now, I need everybody to understand this. I would like everyone to write down slope. All right. Let's just write this on our paper. Slope is equal to rise over run. Thank you for those of you guys who've heard it. Rise over run. Now, do you necessarily have to be going up? No. All right. So you can be going what? Down. All right. So instead of rising, you could be saying I'm going down. All right. Now, how do I calculate how much did I go up? Well, to calculate how much you went up, it's always y2 minus y1 over x2 minus x1. Now, that may not make sense to you until I show you this little piece, all right? Let's say I was looking at my mountain here that we're climbing next week, all right? And I'm going from these 2 points, all right? This point right here is called x1, comma, y1. This is another point, a second point, that's called x2, or I'm sorry, not x, yeah, x2, comma, y2. All right, they are just subscripts indicating that they are 2 different points. That's it. They are just 2 different points. All right, so there's a lot going on. All right, so now what I want to do is I want to show you how someone would calculate the slope. The slope is a ratio, all right? It's the distance that you go up divided by the distance that you go to the right, all right? Now, how do I calculate this distance right here? This distance is defined as y2 minus y1, all right? No, hold up, we'll get there, I promise you, I promise you. The distance between the 2 y values, the distance between y2 and y1 is simply y2 minus y1. That's all it is. All right. Now I have the distance here between the x values is simply x2 minus x1. All right. I'm telling you, if you're not paying attention, you're going to be lost, and there's nothing I can do for you. All right. That's why I try to tell everybody, you got to put on your thinking caps now and try to stay with me. All right. So that's the information. That's how you determine slope. So slope is how fast you go up divided by how fast you go to the right. All right. Well, we're going to subtract it. I'm going to show you why we subtract. All right. In a minute. All right. So again, slope is defined as the rise over run equals y2 minus y1 over x2 minus x1. When you get to advanced math, and I just want you to recognize the symbolism, all right? I'm going to put this up just a little bit, and I'd like everyone to really write delta y. Delta y stands for change in science, and over delta x. That's the symbolism, all right? Now, slope is also another word, and I used to yell at my math teachers like, can't you just tell me one definition? Why do I have to know it 10 different ways? All right, because there are 10 different applications. You have to select what application you're using. We also call it an average rate of change. Average rate of change. You'll hear this a lot throughout your math career. All right. Slope is an average rate of change. All right. So when someone tells you you're driving at 30 miles per hour, that is a rate of change. All right. That is a slope. All right. That's how fast you're going. All right. It's a comparison of 2 numbers. All right. Now, what I really want to do is I really want to break this down for you and show you it's really simple. It's really simple. But if you daydream, you don't pay attention, in a few minutes, when I get down to the bottom of the page, you'll just sit there like, I don't know what I'm doing now. I don't want you to be in that position. All right. Please listen. All right. Everyone's in the same boat. All right. So now we have examples where we have lines. So the first one I'm going to do is I'm going to look at the red line here. All right. And there's a blue line. I know it's not on your paper, but does it really matter? No, because you have to find the slope. All right. Now, what I try to demonstrate here is, please look up now. There are all of these points that are on the line. Do we agree? All right. There's all these points on the line. You don't have to just listen. You don't have to write anything. You really concentrate. I need to get from one point to the next point. So what I'm going to do is I'm going to show you, I went from this point right here, and then I went to this point right here. Now, how much did I go up? 1. How much did I go to the right? 2. So 1 is defined as delta y. 2 is defined as what? Delta x. So our slope of the red line is the change in y. What was the change in y? Over the change in x, which is what? 2. Thank you. Which gives me, Leah, the slope is? That's right. The slope of the red line was 1/2. I went up 1 and over 2. Now, here's the next critical thing. Let's say, for example, you didn't pick those two. All right, let's say I wanted to pick these two. I'm trying to make it in green so you can see it. I got to make it a little darker here. Please look up because this is the important part. I went from here to here. Guess what? I still went up what? And over what? Is the slope the same? Okay, now let's just see. I'm a little wild and crazy. I'm going here. I'm going up here. And now I'm going over here. Is the slope the same? Because it's up how many? And over what? Over 4. And if I go up 2 and over 4, it's still what? It's still 1/2. Now, just to show you something, just to be a little obnoxious about it, I'm going to go from here to here, here to here. Does it look like it's the same? No, it doesn't really look the same, but guess what? It is the same. So I'm going to go up 1, 2, 3, 4, 5, and I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's the slope? Slope is 1/2. Daydreaming. All right, the slope is 1/2. Is everybody good with that? Now, what if I pick this point right here? Look, right here. If I pick this point right here, and I pick this point right here, and I did the rise over run, just for those of you guys couldn't see it. Let's say I pick this point and this point. What's the rise over run going to be? Nope. 1/2. Thank you for not daydreaming, right? It doesn't matter what 2 points I pick. The slope is always going to be what? 1/2. The slope of the line is always the same. Thank you. Go. No, you don't have to go up 1. I could go up, for example, up 0.1 and over 0.2. That's still what? 1/2. You with me? You can just because, listen, and that's why I'm trying to help you with your numbers. That's why it's good that you asked me that question. If you can't go up 1, can it possibly still be 1/2? And the answer is yes. All right, it definitely can. All right. You could go up 0.2 and then you would go over what? 0.4. And that's still 1/2. All right. That's good. All right. Now let's take a look at the blue line. So I'm going to pick these 2 points right here, this point right here, and this point right here. Now I'm going start from the left point. Always go with the left point first. To get here, I went what? How many did I go down? 3. And then I went over how many? 1. Down is, how do we represent down? Negative. So this is -3 to the right 1. So the slope of the blue line is what? -3. The slope of the blue line is -3. Now, if you want to say -3 over 1, that's better. And then we just say it's just -3. Come on, go. What did I just say? Shh. What did I just say? There you go. You answered your own question. You didn't even have to have Katie tell you. All right. You go down 3 over 1. Let's say I didn't like those 2 points. Let's say I picked this point right here. I went all the way down here and I went all the way over here. That slope is still going to be what? -3 over 1. It's always the same. It's always the same. It doesn't matter. All right. So with that being said, let's continue on to question number 14. Horizontal line. What do we always say? Thank you for listening. Slope is 0. All right. The slope is 0. Now, how do I know the slope is 0? Because to go from one point to the other point, I went up how many? 0. So delta y equals 0. To get from this point to the other point, I went over 3. So delta x equals 3. What is 0 divided by 3? Correct, 0. All right, it's 0. Come on, go. Because it's defined, slope is defined as change in y over change in x. It's a ratio. It's always going to be a fraction. I moved 0 up and I moved to the right 3. What? Come on, tell me. I didn't go up anything. I didn't go up anything. I was at this point and I just moved to the right. If you move to the right, if it's a horizontal line, you have to know horizontal line slope is 0. No, very good. It doesn't matter. 0 divided by 4. What's 0 divided by 4? What's 0 divided by 10? 0 divided by anything. There you go. All right, now let's pick this blue line. All right, I like this point right here, and I like this point right here. So on your paper, tell me what the rise over run is. 2 over what? 2 over 5. Come on, everybody should be that quick. Everybody should be that quick. And everybody should go, wow, this is super easy. All right, I went up 2 and over 5. Carolyn, what happens if I don't pick those two? Still what? Yes, slope is still 2 over 5. Okay, let's look at 15. Let's look at the red line first. Who was paying attention? Slope is undefined. Now let's tell you why or how I know it's undefined. Slope is undefined, and we abbreviate undefined with 0 with a line through it. Okay, now, again, how do I know? I just picked 2 points that are on the line. How many did I go up? Delta y equals 2. Delta x was 0. What is 2 divided by 0? Believe it or not, no one knows. All right, 2 divided by 0, we cannot do. Nothing times 0 is 2. That is why this is undefined. All right, it's undefined because in math, you cannot divide by 0. If, for example, you were to take your calculator and say 3 divided by 0, it would say error, divide by 0. Cannot divide by 0. All right, that's why they say it's undefined. Okay, so I'm pretty happy with this. All right, everybody take a look at the blue. All right, everybody take a look at the blue line real quick, and you on your own put the answer to the slope of the blue line. You got this? What is it? Somebody said 3/5. Now, I'm not sure I would trust him, but let's go ahead and everybody else double check him. Is it 3/5? Oh, Caroline said it, so it must be true. We know she doesn't make mistakes. 3 over 5. All right, now, because we're so great, let's go ahead and knock out 16. All right, calculate the slope. Come on, Palmer, this is what I'm talking about. Stop with the games. Stop messing around. Pat yourself on the back. You got one right. Let's try to get 2 in a row. All right. You go ahead and say something smart today. All right. What's the slope of the blue line? Slope of the blue line. Tell me, Liv.
-7.
Now you're. Oh, we're doing. So listen. Again. It doesn't matter what point you pick, but you start with the left point. So if you choose this point and this point, start with the one furthest to the left. All right. Now, it doesn't matter really if you started here, but I don't want to get into that right now. Just trust me, go with the one on the left. All right. Now, to get to it, you have to go this direction. And then you go this direction. All right. So I went down how many? Yes. And to the right, how many? So the slope of the blue line was -7 over 2. And now someone calculate the slope of the red line. I just found this point right here. You can use this point right here. Up 1, 1, 2, 3, 4, 5, 6. It looks like 7 to me. 1, 1, 2, 3, 4, 5, 6. Yeah, I got 1, 7. Slope of the red line is 1, 7.
7. Yeah, this is 7.
No, it's just counting. You're just counting. All right, count the dots, count the squares. All right, now finally, the easy part. All right, the easy part. Now that you know that, I gave you an equation. You're going to calculate the slope using a graph, and you're going to calculate the slope using 2 points. So here we go. Everybody's going to write down for 17, m equals y2 minus y1 over x2 minus x1. Now, if it's necessary, this is x1, y1. This is what? x2, y2. All right. So let's see if we can do this. Y2 is what? -4 minus what? -5. So instead of writing minus negative, just change it to what? +5 over, what's x2? -6 minus what? -2, which makes it +2. Thank you very much. You have to be real careful with the negatives. And so -4 plus 5 is what? 1. -6 plus 2. So your answer we just say is the slope is -1/4. Where did I get the what? -6 minus -2. -6 minus -2. You with me? Double negatives. All right, let's take a look at 19 now. All right, come on now. Write the equation. M equals y2 minus y1 over x2 minus x1. It helps you to learn the formula if you write it. Then, what's y2, please? -11 minus, what's y1? 1 over -10 minus 7 equals -18 over -17, which is 18 over what? 17. All right, easy as that. All right. All right, guys, your job is to finish it up. All right, you're welcome. Finish up. What? You good?